Welcome to InterviewPro. In this video, let's try to solve another LeetCode problem to find the closest binary search tree value. This question was also asked in a number of interviews. You can see the companies listed here. So coming to the problem statement, a binary search tree will be given to us and a target value as well. We have to return the value in the tree that is closest to the target. If we have two nodes with values closer to the given target, we have to return the smallest. First, let's try to recap what a binary search tree is. In the binary search tree, we'll have a root node. The left side of the node will be smaller than the root and the right side will be larger than the root. And this rule will be applicable to all the subtrees. Now that we have an understanding of the binary search tree, let's see how we can solve the problem. The only entry point to the tree is the root node. So let's assume this is our closest value for now. So the closest value is 4. What is the distance from 4 to our target, which is 3.5? 4 minus 3.5 is 0.5. So this is the distance for now, and the closest value is 4. The target value is 3.5, which is less than 4. So our next search value should be towards the left side of the tree. If the target is something around 4.5 or more than 4, we would have moved to the right. But since target is less than 4, we are moving to the left of the subtree, left of the root node. So our current value is going to be 2. And what is the difference now from target to the current value? It is 3.5 minus 2, which is 1.5. And what is our previous difference? It was 4 minus 3.5, 0.5. So what is the closest compared, when we compare 4 and 2, what is the closest value to the target? The one with the distance 0.5, right? So 4 is still our closest value. Now, to decide what is our next destination, the target is 3.5 and the current value is 2. So, if we move towards left, the difference would be more as we are moving farther. So, we should be moving towards right because target is greater than 2. So, the current value will be 3. And what is the target? It's 3.5. The difference from 3 to 3.5 is 0.5. And what was our previous difference? 4 minus 3.5, so 0.5. Now, both 4 and 3 are of equal distance from target. They are at a distance of 0.5. But if you remember the condition given in the problem statement, if we have two closer values, we have to return the smallest. So what is the smallest among 4 and 3? It is 3. So our current closest value will be 3. Now we have reached the end of the binary search tree. So our final answer will be 3. But if there are more number of nodes, we'll continue to repeat this process. So based on the difference between current value and the target, we'll decide what is the closest, and based on whether the target is greater than the current value or less than the current value, we'll decide our next destination, and we'll repeat this process until there are no more child nodes for the given current value. So let's try to see how we can put this logic in the code. This is our problem statement and I'm coding this in C#. So what did we assume first? We assumed that our root value is the closest value because we don't have any other option, right? This is the only node visible to us and we'll assume this is the value closest. So I'll create a variable called closest or closer, you can name whatever it is. I'm just assuming it is closest and the initial value will be root.val. Then we will go down this tree, and every time we update the node, we'll compare the current value with the target. So to track the current value, I'll create another variable called value. I won't assign anything to this for now. and we have to loop through the tree. How long do we loop? Until there are no more child elements. So we'll say root not equal to null. And the current value will be coming from root dot val. Now what are we supposed to do? We have to check the difference between this current node value and the target. So we'll find the absolute difference, value minus target, and we should compare this difference with the difference between closest and the target. So if these two, after finding these two values, if the difference between value and target is less than the difference between the previous closest and target, then we know that this value is the new closest, correct? So I'll use a ternary operator here. If this condition is true, then value will be the closest. Otherwise, closest will not be updated. It will be assigned with the same value. Now, we have also seen another condition where when we reach the node 3, the difference between the target and node 3 is 0.5, and the difference between the closest, which is 4, and the target is 4 minus 3.5, which is 0.5. These two were equal. So let me add that condition also. One condition is if this difference is less than the difference with the closest, and the other condition is, I'll use an OR operator here. Let me put this in a different line. The other difference is these values can be equal also, right? So value dot target equals closest minus target. So in such case, what did we do? We have to always return the smallest. So if there are multiple answers, print the smallest. Now we have multiple answers. What are those? Value and closest. Value is 3, closest is 4 in our previous example. What did we do then? We compared these two things, 4 and 3. If 3 is less than 4, 3 is going to be the new closest value. So I'll add one more condition here. And value less than closest. So if this condition is true, we'll update closest with value. Otherwise, closest will remain unchanged. Let me put this in a different line so that it will be clear. Yeah. So now we have updated the closest. But after updating the closest, we should calculate what is our next destination. When we are at 4, we compare the target with 4. Target is 3.5 and the current value is 4. 3.5 is less than 4, so we move to the left side of the tree. If it is more than, for example, when we were at node 2, target was 3.5. So it is greater than 2. So we move to the right side. Now, what should be our condition? We should update the root. So what will be the root? If target is less than current value, we'll move towards left. Otherwise, we'll move towards right. Finally, when we reach the end of the loop, we have to return the closest. Let's try to run this code. Okay, we have a missing bracket here. Okay, we have an opening bracket here. Let me close this. Now we have the matching brackets. So all the test cases are passed. If I submit, The solution is accepted. Coming to the time complexity, we are going through height of this binary tree. Look at this in this example. What is the height of the binary tree? 4, 2, 1. 1, 2, 3. So 3 is the height of the binary tree. First we saw the node 4, then we went to 2, then we went to 3, and it stopped. So number of nodes that we visited is equal to height of the binary tree. So the time complexity is also going to be the big O of height of the binary search tree. And what is the space complexity? We didn't use any extra space, right? So the space complexity is going to be constant, which is big O of 1. I hope the solution is clear. If you like the content, please like, share and subscribe to InterviewPro. Thank you.